Hi, in this lesson, we're going to focus on two new rules for finding the derivative, and that is product rule and quotient rule. But in order to use product rule and quotient rule, we are going to also be using rules that we learned in a previous section, which are the three that you see here. The derivative of a constant is 0. The derivative of e to the x is e to the x. And then we have power rule, which is the derivative of x to the n, as long as n is a real number, is n times x to the n minus 1. So we'll be using those rules within product rule and quotient rule. So here's our product rule. If we want to take the derivative of the product of two functions, those two functions being f of x and g of x, as seen here, that's equal to f of x times g prime of x plus g of x times f prime of x. Now, addition is commutative, so if you did this in the opposite order, where the second product goes first and the first product goes second, you also get the same answer, which is g of x times f prime plus f of x times g prime. So rules should always be memorized because this is something that will be used in other calculus courses beyond this course as well as throughout this course. So the sooner you memorize them, it'll be easier on you. So let's just talk about quotient rule before we actually use product rule and quotient rule. Here, if we're taking the derivative of a quotient, and the quotient being f of x divided by g of x, that is going to equal g of x times f prime minus f of x times g prime, and that entire difference is divided by g of x to the second power. Notice that the numerator looks a lot like the second version of product rule, except there's a minus sign in between. So it might be easier to memorize the second one instead of the first, but that's up to you. So you can apply this rule as long as g of x is not equal to 0, because then that would be undefined. Okay, so first we're going to practice using product rule. So here I have a product of two functions, e to the x times 3x squared minus 5. So in order to use product rule, I actually applied the first one. I actually wrote out what f of x and g of x are, and then I wrote f prime and g prime below each one. So the derivative of e to the x is f prime is also e to the x. The derivative of g of x is just 6x. And now we just have to plug it into the formula. So this is what you see here. I have f times g prime plus g times f prime. And then in order to present it a little bit nicer, I noticed that each product has a common factor of e to the x. So I wrote e to the x in front. I factored that out. And then I wrote the terms that were left, which is 3x squared. So I put that one first, and then plus the 6x and the minus 5 at the end, so that they are in decreasing order with the highest degree first. And so that's your derivative. So the product rule provides you with the same answer for derivatives as using the definition of the derivative, but the definition of the derivative would be quite a bit of work in algebra to apply to something like this. So the rules just make things a little bit easier for us. All right, so here the question is to find the slope of the tangent line to the curve y equal to the square root of x times 6x plus 1 at x equal to 4. So remember, the slope of the tangent line to a curve is basically the derivative. The derivative represents the slope to a tangent line to a curve. And here, this is a product of two functions, with the first function being the square root function. So I wrote it as x to the 1/2 to make it easier to find f prime. And g of x is the 6x plus 1, so that's right here. So g prime is below in the second line, so and as well as f prime. So f prime is 1/2 x to the negative 1/2, and g prime is just 6. Okay, so now I need to put this all together. in terms of what the product rule says. So product rule says f g prime, which is what I have here. So now instead of calling it y, this is y prime. So y prime is f g prime plus g f prime. And then I just wrote it a little bit different. I put the 6 in front. So this is 6x to the 1/2. And I combined these as a single fraction. So I have 6x plus 1 over 2x to the 1/2. So you can see that I have the sum of two expressions with different denominators. So I got a common denominator. So the first expression has to get multiplied by 2x to the 1/2. So if you multiply top and bottom by 2x to the 1/2, you get what you see here, 12x. And then the second expression stays the same as 6x plus 1. Now they're all with a common denominator. So I have like terms, the 12x and the 6x become 18x. So your derivative is 18x plus 1 over 2 square root of x. But now I have to actually compute it at x equal to 4, as stated in the problem. So you plug in 4 for x, and your numerator becomes 73, and your denominator is 2 times square root of 4, which is just equal to 4. So the slope of the tangent line to the curve at x equal to 4 is 73 over 4. All right, so now we're going to get a chance to use the quotient rule because this is a quotient of two functions, 2x being my numerator, and that's what we call f of x, and the denominator is this cubic, so that we call that g of x, so that's x cubed minus 1. So just like in product rule, you need to know what f prime and g prime are in order to apply quotient rule. So that's here in the second line. The derivative of f is 2, the derivative of g is 3x squared. So referring back to the formula above in the boxes, the quotient rule is g f prime minus f g prime. So you're really just going across like this, g f prime minus f g prime. So don't forget the minus, that's part of the formula, over g of x squared. So that's the whole thing is divided by x cubed minus 1 to the second power. So we can simplify this numerator. So I distributed the 2 to the x cubed minus 1. And I also multiplied these two. So you get 6x cubed. So then you can see that you have like terms. So 2x cubed minus 6x cubed becomes negative 4x cubed minus 2 over x cubed minus 1 to the second power. This is a perfectly fine answer, but I decided to factor out a negative from the numerator. So the negative goes in front of the fraction bar, and therefore the signs of 4x cubed and 2 change. So both of these answers at the end are equivalent. All right, so that was quotient rule. So we're going to get a chance to use quotient rule again on this next one because we want to find the derivative of h of t equal to 2t cubed plus t over 3e to the t and evaluate it at 0. So we want to know what h prime of 0 is. So again, this is a quotient of two functions. So here you have to state what f and g are. So I have f is my numerator, 2t squared plus t, and g is my denominator, 3e to the t. F prime is 4t plus 1, and g prime is 3e to the t. So now we plug that into our formula. Remember, the formula is g f prime, so you have to multiply in this order first, minus f g prime, which is what you see on top. And then my denominator is the g of x, which is 3e to the t to the second power. All right, so just like a previous example that I did in this lesson, the products in the line above have a 3e to the t in common, so I factored that out. And then I was left with 4t plus 1 minus 2t squared minus t, because you have to distribute that negative there. And my denominator, when you square it, it becomes 9e e to the 2t. Remember, with exponents, you multiply the exponents. So when you have a power raised to a power, so it becomes e to the 2t on the next line. All right, so inside of the parentheses, I do have like terms. So this becomes negative 2t squared plus 3t plus 1. But notice that the 3e to the t, this one, will cancel with some of what's in the denominator. So the 3 and the 9 cancel, so you end up with 3 in the denominator. And e to the t in the numerator and e to the 2t in the denominator leaves you with just an e to the t in the denominator. So that expression is as simplified as can be, but now I need to evaluate it at 0, which is what you see here. So when you plug in 0, you end up with 1 in the numerator and 3 e to the 0. Well, e to the 0 is 1, so h prime of 0 is just 1/3. Okay. So here we want to find the equation of the tangent line to f of x equal to 2x plus 1 times x cubed minus 3 at the point 1, negative 6. So in order to find the equation of a line, we need two pieces of information. We need a slope and a point. Well, the point is given, so that part is easy. But we need to compute the slope, and remember the slope is the derivative. So my function is a product. So again, I have to use product rule. So identify your f and your g. With product rule, it doesn't matter which one is f and which one is g. With quotient rule, it does matter. So I'm going to let f be 2x plus 1 and g be x cubed minus 3. F prime is 2, g prime is 3x squared. And then we plug it into the formula. So I did f g prime plus g f prime. And then in the next line, I distributed the 3x squared and the 2 to get 6x cubed plus 3x squared plus 2x cubed minus 6, which leaves us with some like terms. And so we get 8x cubed plus 3x squared minus 6. All right, so that's that derivative is as simplified as it can be. Now we can evaluate it at 1, because remember our point here, the x-coordinate is 1. So plug in 1 and you get that your slope is 5. So the slope is the value that we were looking for in order to compute in order to find the equation of the tangent line. So we use a slope of 5 and a point of 1, negative 6. We plug it into the point slope formula, which is right here. So y minus negative 6 equals 5 times x minus 1. So that becomes y plus 6 equals 5x minus 5. Subtract 6 from both sides and you get that the equation of the tangent line to the curve at the point 1, negative 6 is 5x, y equal to 5x minus 11. All right, so here's another problem. The problem states, consider the graph of y equal to 9 minus x squared. Find the coordinates p on the graph for which the tangent line passes through the point 5, 0. All right, so I drew 9 minus x squared. That's the parabola. It's got a vertex at 9, at 0, 9. The point P is here. And that point, that line that goes through P also goes through the point 5, 0. So that's stated, that's right here. So the graph of what we're trying to find is represented here. And remember, we don't want to find the equation of the line like we did in the last example. I just want to know what the coordinates of P are. So at the very least, I know that P is in quadrant 1. So I know that X and Y should both be positive. Otherwise, this graph wouldn't make very much sense. All right, so let's see how we're going to figure this out. We know that Y prime for 9 minus x squared is negative 2x. And remember, that represents the slope of this line that we see here in this bluish green color. And we know that that line also goes through the point 5, 0. That's all given in the problem. So I'm going to use my point slope formula again, but notice that my slope is a variable expression. It's negative 2x. So I have y minus 0 equals negative 2x times x minus 5. This is your point slope formula right here. So if I simplify that, the left side just becomes y, and the right side, when you distribute, gives you negative 2x squared plus 10. Remember, that's the equation of the line. Even though it's a quadratic, so it might seem a little weird, it's a general equation of the line because we don't really know exactly what that slope is because we don't know exactly what the point is. But we do know there's a relationship between the line and the parabola, and that relationship is that they intersect at P. So that's exactly what we need to figure out. We need to find where 9 minus x squared and negative 2x squared plus 10x intersect in order to identify what the point P is. So in order to find where two graphs intersect, we set them equal to each other like you see in this line. So I have 9 minus x squared equals negative 2x squared plus 10x. So I decided to move all of my terms over to the left because basically I'm dealing with a quadratic equation. So when you add 2x squared and subtract 10x, you get this new equation, x squared minus 10x plus 9 equals 0. This is factorable because now we have to solve it. And you get x minus 9 and x minus 1. Those two factors equal 0, which means that x is equal to 9 or x is equal to 1. In order to find out what the y values are, you have to plug them into, remember, 9 minus x squared. So if you plug in 9 in here, x equal to 9, you get y is negative 72. Well, this set, 9 and negative 72, this is in quadrant 4, so this can't possibly be an answer. But when I plug in 1 into 9 minus x squared, I get that y is 8. So this is in quadrant 1. This sounds more reasonable, and this definitely looks like it could be the point 1, 8. So we have found the coordinates of P. Okay, that's it for that lesson. Give the homework a try. Good luck.